All right, you guys. So if you go into your workbooks, you'll notice that pages 241 through 248 all look very similar. And so what's going to happen is for the next couple days, so today and Wednesday, we're going to do one example and have you do one example. So for instance, Monday we're going to do number 1 and we're going to have you do number 2 for practice. And then Wednesday we're going to have you do number 3 and we're going to have you do number 4 for practice. And then on the last week of school, we're going to do number 5, and then number 6, 7, and 8 are going to be the ones for your final. So if you look if you look on this sheet, 246 through 248 are going to be the papers that we ask as your project to turn in for your final for our class. So what we do now is just practice for what we're asking you to do then. So we want to make sure that we're getting good practice in so that we can solve these when it comes to our project. So we're going to look at number 1 together today, and then we're going to have you do number 2 as homework. So looking at number 1, they all look very similar. So we're going to do number 1 together. So the first thing that we're going to do is it asks you to factor the equation to find the roots. Write the roots as points. So all it wants me to do is factor this equation. So I want to know what multiplies to give me -5 and adds to give me -4. So if we think what multiplies to give us -5 and adds to give us -4, we would have -5 and +1. Right? -5 times 1 is -5. -5 plus 1 would give me -4. So then in order to make these roots, well, all we're going to do is now solve each of these for x. So we set them both equal to 0 and we solve for x. So if I add 5, I get that x equals 5, which as a root would be 5, 0. The x value is 5. And then if I subtract 1 here, I get x equals -1. So that gives me the root of -1, 0. So that means I can graph these 2 points as points on our quadratic graph. So I would graph 5, 0, which is right here, and -1, 0. So that's our first part. So then the next part is to ask us to use the quadratic formula to verify that you get the same answers here. So we're going to use these same x squared minus 4x minus 5. So remember, when we did the quadratic formula, we figured out what a, b, and c are. So a in this case is 1 because there's an imaginary 1 in front of x squared. B is -4 and c is -5. So remember, when we did the quadratic formula, the first thing we did was b squared minus 4ac. So if I do that, that would be -4 squared minus 4 times 1 times -5. Right? A is 1, c is -5. So -4 squared means -4 times -4, which is +16. And then -4 times 1 is -4. Times -5 would give me +20, because a negative times a negative is a positive. So then 16 plus 20 would give me 36. So now, by doing this, when we get a positive number, that means we have 2 real solutions, which is what we're looking for anyway. So that's a good sign. So then we're going to use our quadratic formula, which is -b plus or minus the square root of b squared minus 4ac all over 2a. Now remember, when we stick this into our formula, we already know that this part we solved for. We already know that this b squared minus 4ac is 36. So when we rewrite this, we have x equals negative of -4 plus or minus the square root of 36 over 2 times 1. So the nice part, negative of -4 is 4. And then the square root of 36 would be 6. So I have plus or minus 6 over 2. So that means I have 2 answers here. When I do 4 plus 6 divided by 2, and when I do 4 minus 6 divided by 2. So 4 plus 6 would give me 10. Divided by 2 is 5. 4 minus 6 is -2. Divided by 2 is -1, which those are the 2 answers we have here. So remember, this part said to verify. So all I wanted to do is show my work to show that I still get 5 and -1 like I did for part A. I'm sorry it's so messy. The quadratic formula takes a lot of work. You may consider doing your work on a separate sheet of paper and turning that paper in with this if you can't write small, like I clearly can't. Alright, so the next part is part C, which is to find the y-intercept. The y-intercept is really easy to find. You make x equal 0 and simplify. So I have y equals 0 squared minus 4 times 0 minus 5. All I did was take this equation, and everywhere I saw an x, I put a 0. So 0 squared is 0. Negative 4 times 0 is 0 minus 5. So 0 minus 5 would tell me that y is negative 5. So my y-intercept was when I made x 0, I got negative 5 for y. So then I can go to my graph, and I can graph 0, negative 5. So that would be right there. Alright, so then our last piece would be to complete the square to write the equation in vertex form so that we know the vertex. So we're going to take our original equation and we're going to complete the square so that we can write it in vertex form. So I have x squared minus 4x minus 5. So remember, for vertex form, we separate the first two terms with a plus blank, and then on the outside we write a minus blank. And then to figure out what we fill in those blanks, we did b divided by 2, and then we squared it. So I would have negative 4 divided by 2. Negative 4 divided by 2 would give me negative 2. Negative 2 squared gives me positive 4. So that would give me y equals x squared minus 4x plus 4 minus 5 minus 4. So that's where I put both those 4s in my blank. So then remember, we factor this piece. So what two numbers multiply to give me positive 4 and add to give me negative 4? So remember, when I factor, I want both of my terms to look exactly the same. Since b is negative, that means both of my factors are going to be negative in this case. And then two numbers that multiply to give me 4 and add to give me negative 4 would be negative 2 and negative 2. So that would be negative 2 squared, and then negative 5 and negative 4 make negative 9. So here's my vertex form. And then remember, to find your vertex, you take the opposite of what's inside the parentheses. So since it's a negative 2, my vertex is a positive 2. And then you take exactly the number on the outside. So this is going to be a negative 9. So my vertex is 2, negative 9. So I go to 2, negative 9. And so I have all of these points that I then can connect. And I didn't do a very good job connecting, but I can use them to connect to make my parabola. So all of those pieces helped me make my graph. So hopefully this made sense. Like I said, your project for your final for our class is going to look just like this. So what I'm going to have you do is go try on page 242. I'm going to have you try the next example and turn that into me.